everyone. Good morning, afternoon, evening. Welcome to today's webinar, The 7 Most Expensive Design and Operational Mistakes in Cannabis Facilities. Coming to you live from New Jersey. I saw a bunch of New Jersey folks tuning in, so good to see all of you. And we have another really lively, packed house here. We have people viewing from more than 31 states and at least 18 countries. So thank you all so much for joining us. I'm Noelle Skidinski with Cannabis Business Times, and with the amount of information our speakers have to get to today in a pretty short amount of time, I'm going to keep it very short on my end. I just have a couple of quick things to go over, and then I will turn it over to our speakers to get started. First, I want to thank our sponsor, Pipp Horticulture, for making this webinar possible. We've been doing webinars with Pipp for years, and with Michael Williamson, who will be introduced shortly, for years now, and just really appreciate the educational nature and expertise that they share with our audience and supporting our mission of helping cannabis cultivation businesses succeed. So thank you to Pipp. If you're not familiar with Pipp, they are the industry-leading provider of mobile vertical grow solutions with installations in over 3,000 grow rooms worldwide. With more than 40 years of experience, Pipp has engineered a variety of cost-effective solutions that enable you to exponentially grow your production without increasing your square footprint. I just have a couple quick housekeeping notes. We will be leaving time at the end of the webinar for the speakers to answer your questions. So you can submit your questions at any time during the webinar using, if you would, the Q&A box on your screen, not the chat box. So you should see a little box at the bottom of your screen with a question mark in it, or 3 dots that you can click, and then you should see that box with the question mark in it. So if you would just submit your questions there so the speakers can be sure to see them, that would be great. And our speakers have also graciously offered to answer any questions that we don't have time for in a blog post, and they will send those out via email as well. You're going to see 2 quick polls pop up on your screen during the webinar. If you would please just take a moment to answer those, or actually just take a second. You should see a poll popping up any second now. We will also be recording this webinar, and we will be sending a link to all registrants, so all of you within a day or two, usually within a few days max. So if you have to leave for any reason, not to worry, you will get to see the entire webinar. With that, I am pleased to introduce our first speaker, who will kind of take the reins here. Caitlin Gorileski is a horticulture solutions professional specializing in controlled environment agriculture and cannabis cultivation infrastructure. Caitlin is the director of horticulture solutions at Pipp, where she focuses on helping growers optimize space utilization, streamline processes, and support high-performance indoor agriculture environments. So with that, I am done. I'm now pleased to turn things over to Caitlin. Caitlin, welcome.
Great. Thank you, Noelle. I appreciate the introduction. Thanks, everyone, for joining. Today, we're going to walk through the most expensive design and operational mistakes we see across cultivation and post-harvest facilities. These are real-world issues that directly impact yield, labor efficiency, and sorry, that poll keeps going up, and ultimately ROI. The common thread across everything we'll discuss is this: most of these mistakes happen early during design and planning, but the consequences show up for years during operations. Our goal is to give you practical insights you can apply to current or future projects to avoid these long-term inefficiencies. Now to introduce our panelists. First, we have Brent Barnes from Claybourne Co. Brent is a classically trained plant breeder and brings a valuable perspective from both traditional horticulture and as a vertically integrated brand-focused California operator. With experience across cultivation, post-harvest, and product execution, his insight into how facility design impacts downstream quality and consistency will be especially relevant today. Next, we have Mike Lentz from Klutch Cannabis, one of the leading operators in Ohio. Mike brings a strong operator's perspective with a wealth of experience in new construction, phasing, and scaling large-scale cultivation and operations while maintaining consistency and performance. And finally, we have Michael Williamson, co-founder of Greenhouse Industries, which was acquired by Pipp in 2017. Michael brings over 40,000 hours of hands-on owner-operator cultivation experience and has been involved in the design, commissioning, and optimization of more than 7 million square feet of facilities globally. His expertise sits at the intersection of facility design, operations, and plant performance. And if you haven't already answered that poll, I know that we just put up another one for you. Starting with HVAC, between cultivation, breeding, operations, and facility design, we've got a well-rounded view on what works and what doesn't. Let's start with one of the most expensive mistakes we see, HVAC. One of the most common design issues that creates operational and significant performance challenges, especially in flower rooms, is miscalculated and undersized HVAC and D. Where do engineers and operators most commonly misalign with HVAC assumptions to maintain an optimal VPD? Michael, if you want to kick it off.
Yeah. Thank you, everyone. Thanks for joining us wherever you are in the world. This is obviously a great question. It comes up all the time, and honestly, it's one of the primary root causes of underperforming flower rooms that we see across the country and globally. So, at a high level, HVAC and dehumidification is managing two things: your sensible load, which is temperature, and your latent load, which is the moisture in the air. So in cannabis, especially in the flowering stage, it's almost always the latent side is where we see things and systems kind of fall short. This misalignment is fairly straightforward. Some engineers, particularly those with less experience in the nuances of cannabis and irrigation strategy and CEA, tend to design around a static set of assumptions, while operators are really not managing like a static system. It's a biological system. It's dynamic, and so it changes throughout. So an example would be transpiration is not static. What you see in week 2 of flower is completely different from what you see in week 6. A high-performing cultivar under high light intensity can transpire 2 or even 3 times more than a conservative model assumes. And as the canopy fills in, you go from air moving through plants and moving around like dense walls of biomass and canopy, which further limits how effectively moisture can be removed. On paper, models often assume fixed inputs like plant count, canopy size, irrigation rate, leachate volumes, stable environmental conditions. But the reality is that all of those variables are changing throughout the growth cycle and maturation cycle. So as light levels ramp, irrigation strategies shift, and plant mass increases, transpiration becomes both higher and more variable than originally designed for. The second major factor that I see a lot is designing around an average condition instead of the peak demand. Most systems look adequate on paper. I mean, really everything looks good on paper, but most systems look good on paper because they're sized for typical load. But flower rooms don't fail under average conditions. They fail when they're under peak latent load, usually mid to late flower, lights on, when transpiration is at its highest. That's when we see humidity start to drift, VPD falls out of range, and operators shift from controlling their environment to reacting to their environment. So essentially, the mechanical system is designed for a version of reality that doesn't exist once the room is fully loaded and operating at peak biological demand. Mike, I'd love to get your perspective on this from an operational standpoint, especially how you see that imbalance between sensible and latent load play out day to day and how irrigation strategy ties to that.
Yeah, absolutely. Again, great question, and we could talk for probably hours about this. But a lot of the alignment I think happens in the early design phase when I think cultivation strategies are not necessarily defined with the vendors and the engineers and the people that are driving the decisions and the inputs being made around the design of the system. So like, for example, the latent load, like you talked about, like if that's not really defined, it's based off of, say, you need to move 1,000 gallons of water into the room. Well, say, a new grower comes in and changes some grow strategy and increases plant count, which holds more substrate in the room, more water holding capacity, more water in the room, more moisture needs removed, then your VPD can start going out of whack, and it makes the room much more harder to control those, tight parameters that we're targeting, along with misalignment on, I think, Watering typically happens through in a 12-hour period in a day. Now, are we designing a system that needs to pull this out in 24 hours? Otherwise, you're going to have it's going to take a long time to get down to your set point. So if you need to design systems around a 12-hour period, right? Or like, what is that peak demand that, Michael's talking about there? So like, essentially also with, the temperature of the room, at lower temperatures, the equipment is less efficient at removing moisture. So I think just having uh, somebody to drive and control these inputs and a good strategy in place when designing a system is just crucial to the success of room conditions. And I know other than that, I know Brent has a lot to speak on this topic, so I'll pass it to him.
Thanks, Mike. I agree
Yeah.
with Mike a lot on this. It's, being an operator and kind of understanding engineering design, it's like we could talk for hours on this, but I think one of the things that people miss very often is just airflow. How your microclimate is going to be affected by dynamic airflow in the rooms, whether that's uniform air mixing or whether that's just uneven airflow due to lack of mixing chambers or lack of capacity or all these different things and spreading that through a dense canopy. Our systems, when you're going through and you have very long bench runs, it's like laminar airflows through the canopy really help blend that air and build that canopy so you're lacking in microclimates. Because without a dynamic airflow system and blending of the capacity and the humidity and things like that, you're not going to get good, adequate control of temperature or adequate control of humidity. A lot of that comes down to really what Mike was talking about with communication with the engineers. It's like the engineers they don't understand our systems exactly. They don't understand plants and how the capacity really interacts with transpiration. Having that clear communication between design and operations and future operations, I think, is a very key thing that we have to concern with when designing facilities. We really have to think about this stuff very heavily. Airflow is by far one of the biggest things that I would recommend people look at very heavily, whether it's under canopy or above canopy, thinking about that stuff within the system for capacity.
Well said. Thank you, Brent. Now, do we feel that operational discipline can compensate for undersized HVAC, or is that just a losing battle?
Well, that one, that one's tough. It depends on how undersized it is, but I think you can manage it. I don't know. It's hard to overcome it, I would say. So, like, for example, when Brent's talking about airflow, right? Like, there's little subtle things you can do to like HVAC equipment to utilize the performance of it. You can slow the blower speed down a little bit to increase moisture removal. More contact time across coils can pull more water out. But at some point, I think, you can manage irrigation strategy a little bit. There's a little bit you can do with reducing plant count, increasing veg time to try to keep the same, output that you're desiring. But at some point, you could see diminishing returns. And you're going to have to do a business case on, do we need to right size our units at some point? So there's subtle things you can do, but you're very limited on like how to manage an undersized or misaligned system.
Yeah, we're aligned there. This is one where it really depends on how undersized you are and what you can kind of get away with on your discipline. But we do see this quite often, and operators are having to make tough decisions and compromise with limited levers that they can pull. So, Mike, you highlighted a lot of them, but I'll kind of reinforce them a little bit. As cultivators, we only have so many levers that we can pull to control um, a lackluster system or something that's just not quite capable enough. And so, what do those look like, right? So we can run a drier irrigation strategy. We can run potentially a warmer climate and capture more humidity removal, as you were talking about. You can slow down airspeed so you get more time across coil. You can also start looking at your planting density. Um, one of the challenges is if you're really undersized, it's not even about planting density. I think a lot of people, there's a misnomer there. I really believe that HVAC and latent load should be calculated off of canopy per square foot. And where a lot of these guys go wrong is they look at it per plant. And the truth is, this plant's pretty incredible. So even when you do reduce the density, I think it helps a little bit, but it tends to fill in those empty spaces. It's gonna chase where the light is going versus kind of competing and crowding. So when we start to like do some of these levers, though, it comes at a compromise, which unfortunately usually results in slower growth, lower yield potential, and some level of compromise on plant performance. So the bigger issue is day-to-day reality. You're always managing around some kind of limitation. The team becomes reactive instead of proactive, constantly adjusting to keep the room from drifting out of spec. And you're kind of operating in this like high cortisol level of stress as you're trying to kind of, you're let's say if you thought you were driving a yacht, if you're an indoor guy, you're now like kind of managing like a sailboat, and you really have to like react with the little bit of levers that you pull. So for me, operational discipline is really a defensive tool. It's not a performance strategy, I guess, is what I want everyone to kind of take away from that. And if you want consistency and high performance, the infrastructure has to be aligned with the actual biological demand of the plants. Otherwise, you're just managing constraints instead of optimizing a system.
Great. Thank you, Michael. And what role does airflow strategy play versus the just tonnage and capacity?
I
But
I think, you know, the clarification, it's like to clarify capacity and really condition the room's temperatures and humidity and things like that. The airflow really acts to condition the individual plants, the microclimate that could be created within there. HVAC capacity, it removes heat, it removes moisture, and that overall environmental quality is what affects plant growth the most. And without adequate airflow strategy, a lot of what we're doing is creating microclimates throughout the canopy. It's like, and the canopies are rather large in a lot of these situations. So your microclimate can sway and have variability that's huge, plus or minus 10 degrees or plus or minus 10% humidity. And when you're tracking BPD or you're tracking just plant growth and vigor very accurately, and you're trying to bring uniformity to a system and uniformity in yield or quality and things like that, the airflow is really what's driving the capacity to do its job. And we have to try to do that because those hot spots, those humidity areas and things like that, that's where you're going to go kind of back to where Michael's saying it's like it's going to decrease plant growth. And our goal is that we have 8, 9, 10 weeks, whatever your cycle time is, to grow as much at the highest quality possible per square foot. Every business model in cannabis kind of follows that role. And without an adequate design, you're not going to be able to stabilize VPD and thus stabilize transpiration in the plant, which is what's causing that active growth to happen at its peak. There's a lot of things that happen with that. And, I'll pass it off to Mike. It's like he can kind of speak on this too.
I can piggyback off of
Yeah.
that for sure. I mean, you really nailed it on every way. And like even when you think even the first assumption is, hey, my system might be undersized. It's if you don't have adequate airflow, your system might not even be undersized. You're just running it insufficiently. And like that's one of the things, you'll see in some of these larger rooms. It's like when you start getting the proper airflow, you can start to create a swamp cooling effect through the canopy that Brent's talking about, which is that transpiration rate. You increase transpiration rates, you increase nutrient absorption and plant performance, really. And also equipment performance at the same time. So, you know, one of the first steps to like combat, hey, is my units undersized or is my airflow sufficient? Now, undersizing just to also stay oversizing can be just as bad as well. When your compressors are not turning on as often or they're over drying the room, and then your rooms start to get this peak and valley on your environmentals, which that inconsistency there throws off VPT and transpiration rates as well. And so having a good design system and I mean, some of these systems, you get it right, you get the right airflow, you're plus or minus a half a degree throughout a tiered system, and which is amazing control if you can time it and size these things adequately. So yeah, airflow and pushing it through the canopy plays almost just as much of a role as like, is my system working efficiently? So. Yeah, it's all a big puzzle that plays that's symbiotic together. So
Yeah, thank you, Mike. I feel like we probably could have taken up the whole hour to cover HVAC. But we'll move on to electrical and staying on core infrastructure. Power is another area where assumptions can quietly derail a project. We often hear the building has plenty of power, or so I think. How often is that assumption wrong, and what are the real consequences when teams discover the true demand too late? Michael?
Yeah, this is a big one. And being completely honest, I have like a little bit of like trauma and PTSD from this on multiple jobs over the last, 18 years. So this one for me is probably one of the most critical pieces of diligence you can do before you ever commit to a building or any infrastructure. The reality is power is often assumed and it's not actually validated. So teams here, yeah, there's plenty of power. And typically when I ask someone, I'm like, how's the power? It's my first question when they're like, oh, we got a building. It's like, how's the power? If they say there's plenty of power, it's already like an immediate yellow flag for me personally, because if I ask you how much power it is, you usually should be like, oh, it's 480 volt, three phase, 4,000 amps. Like if, that should be the response if you have plenty of power in most cases. So when they just say kind of like this blanket statement, it's usually like this is going to be a problem. But where it breaks is there's no detailed understanding of the actual like loaded demand. So when you layer in the HVAC, dehumidification, lighting, irrigation, controls, and then factor in all the ancillary power needs, that's when we're looking at like peak demand and startup loads. And so the numbers are almost always higher than anticipated. In multi-phase build-outs, most teams aren't accounting for future expansion at all in some cases. And then the biggest issue that I really see that really just cripples, I mean, it could be the difference between starting and not starting a project is timing. So if you don't validate power before you sign that lease or purchase that building, you've really already lost leverage. These problems typically show up late during design, construction, or commissioning when you're already committed and your options are limited. So, like from there, the consequences start to stack up pretty quickly. So, like in a best case scenario, you're forced to do some kind of value engineering exercise and start compromising equipment and system capacity. Your average scenario, you're dealing with utility upgrades, new transformers, new switchgear, adding months and sadly sometimes years to the timeline. And the problem is that was never anticipated nor planned in your financial modeling. And that's where that real constraint happens with investors and owners. So, worst case, you end up with a power limited facility from day one, and now you physically can't turn on your HVAC or your lighting the way that it was the facility had intended. So, these lead times, it really depends on the local municipality and the utility. But when we talk about high voltage, three-phase power, um, it can be like a 6 month upgrade is like things went pretty smooth. So this 6 months can turn into 2+ years in some extreme cases. So just something to be aware of, not to mention the cost of the financial upgrades can really be brutal. And that directly impacts performance. If you can't fully power your environmental system, you're not going to hit your yield, your quality, your consistency, the kind of the big three. And then I guess if there's anything that anybody is in the early stages that can take away from this, power needs to be fully modeled and validated before you commit to a building and not after. And then from there, you need to design for your peak load and future state, not just what you think you need today, essentially.
Wonderfully put, Michael. I couldn't agree more. Thank you. Brent, what are the most commonly overlooked electrical provisions in cultivation rooms that operators wish they had included once they're live?
Yeah, even to piggyback off of Michael even more, it's like so many people plan a facility for day one. They're not looking into their future. They're not looking into future growth. And as a business, we're always trying to expand our business. We're always trying to get bigger, whether that's through sales, whether that's through, operations, whether that's through yield. It's like all of these things are consuming power in one way, shape, or another. And you definitely find that as you build out facilities and you're growing in size, not just growing as a pun for cannabis, a lot of what you do is you put yourself into bottlenecks for power and simple things like convenience plugs. 120 amp or 120 volt plugs. It's like we start a facility and we don't want to install a whole bunch of them because we don't think like, couple of breakers worth, 40 amps worth, 30 amps worth of power per room is plenty. And Mike and I were kind of joking around about this because, you plug in a couple of vacuums into that 15 amp
Yeah.
anything to
Yeah, it could definitely, and you're totally right. It's like all these little things that are just drawing power, but in a vacuum, it becomes a lot of power, and you start overloading panels. Then you start realizing a lot of these panels, you only can use 80% of their capacity. So a 100 amp panel, you only can use 80 amps if you don't want nuisance trips. Equipment runs harder in the summer when you got a big black roof on a building and it's just,
it?
yeah, compressors are running harder, the draw is more, and you'll see almost 30% increase in just demand just in the summertime and you have to do, load studies on a building, So like it goes all the way down from the contractors mislabeling all your breakers or not labeling breakers and constantly chasing that around, that delays. I mean, I just from the past, mapping breakers can take a lot of time. So from that to even getting into say, oh wow, we need a power upgrade. Well, did we even look at, can the utility company and the substations even support that power upgrade? They might be 3 years out on a power upgrade before you can even do a power upgrade. So like just going that extra layer deep into your electrical infrastructure and what the business plan is, and just making sure you're checking boxes. There's simple things you can do like on the front end. Hey, I know I'm going to upgrade power. Well, let's run some conduit in the building that's empty before while we're here and mobilized. All right. Easy insurance. You'll save a lot of money in the future on remobilizing. Understanding connected and demand load when sizing these things, because you end up, if I calculated every light was on at all times, that's a connected load, and that's going to say your electricity demand is through the roof. But in reality, you're running half the rooms on, half the rooms off, and that's actually cut in half. So, like being able to communicate that stuff in early design and understand what the true load of the building is and put some real thought into it will help avoid some of these ultimately very damaging decisions can be, you know.
Yeah, well said. Thank you, Mike, and thank you,
Yeah.
Brent. Now let's shift to something that seems simple but consistently creates operational issues. If you had one non-negotiable standard for floors and drainage, what would it be? And Michael, I know you see a ton of this, so I'll let you kick it off.
Yeah, I'm probably gonna have to do two non-negotiables. The majority of the floors should be flat and level, especially on the multi-tiered kind of mobile systems. And that drainage, I like there to be an intentional slope that's towards a drainage about 6 inches from each side, because you typically have your underbench plumbing and leachate that hovers over that trench drain. And depending on the grate size, sometimes they get really thick grates, but you'll get this splashback. So you're like, oh, it hovers over, but then you get maybe 30% of it splashes outside of the drain. And that little 6 inch taper on each side helps that drain back to center, and you don't have pooling going on and stuff like that. The other one for me is, what am I sealing my floors with? So concrete is porous. It allows moisture and vapor to move through it. You'll hear people say that concrete breathes. It's true. It releases trapped water from within the slab to the surface over time. So for sealing concrete, when I have the options in the budget, I really recommend a urethane cement system with an integrated cove base. So the cove base is that little part on the side there. I want all that to be one piece. You can almost think of it as like a bathtub. And so I like the urethane cement concrete better than your typical three-part epoxy in the flower rooms because it handles moisture vapor, temperature swings, and aggressive cleaning without breaking down. Epoxy is more rigid and moisture sensitive. So in these environments, you'll see that it'll look really beautiful when you install it, but then over time it tends to peel and crack and then requires more ongoing maintenance. What about you, Mike? I know it's not the sexiest topic, but
Yeah. Yeah,
I'm sure
that
you got some good insight.
absolutely. I guess, you nailed it with all that. And when it comes to, I guess, non-negotiable, it's like irrigation runoff drains, right? Like Mike's talking about, like that's a you got to be able to get the water out of the room. That also helps with just your HVAC capacity, right? You're pushing all that runoff out of the room faster. So like this all plays they all play a part. They're all interconnected. Non-negotiable would be that when it comes to, there's also sanitation drains, right? So you can throw sanitation drains throughout the rooms and throughout these, that just to, you know, the first time you have to shot back up like 100 gallons of water, you're going to be like, man, I really wish we would have put a sanitation drain in. But so all those things are become just a non-negotiable for me. And even if you don't have the infrastructure when it comes to, sewer or the infrastructure of the building to be able to push that water out, you got to figure out sump pump systems or central lift station systems, something to be able to push water out of those rooms, collect and out of the building. Um, yeah, I mean, it's a non-negotiable there.
Sorry, try to get you guys to limit it down to one, but I appreciate the input. And yeah, setting the right foundation is everything. Now, what mistakes do you see with drain placement relative to racking and benching layouts? Michael, we deal with this all the time. So I'll let you start.
Yeah. One of the big ones is it's kind of an afterthought. And so like when you're putting in drainage, like that's early, you're cutting up your slab. So if you didn't get that right up front, it causes monster issues downstream. So at a high level, drain placement has to be aligned with two things, water flow and serviceability, in my opinion, and not one or the other. So from a design standpoint, at Pipp Horticulture, let's say in a larger room where we have 24 feet or greater rows or rack length runs. It's a tricky one to say. Um, the trench drain should be centered and running perpendicular to the rows. So typically in the earlier designs, we saw a lot of people, and they still do it today. They'll put the trench drain perpendicular, of course, but it's behind the racking system, and they in some cases have 6 inches or a foot or 2 feet to work with. And so it's kind of back there where microclimates tend to exist. It can be really hard to service that. It's kind of out of sight, out of mind. And that's where you can really, when you lose visibility on stuff like that, I think that's when problems go unnoticed. So it becomes hard to clean properly, which can lead to microbiological buildup and other issues we're going to talk about in a minute. And ultimately, you're increasing your long-term contamination risk. So drainage to me really it's yes, it's facilities oversight usually, but if it's not properly maintained, it can be the source headache for your IPM team. So I guess what I want people to be thinking about is if you can't easily see it, access it, or clean it, there's a high probability it's going to become a problem at some point. So drainage needs to be designed not just for where the water goes, but also how the team actually maintains that space on a regular basis.
Yeah, that's nailed it there. And even placement on design, like, you talked about a pitch, even like when you're throwing out either sanitation drains, irrigation drains, whatever is getting put out, designed, you want to make sure that you triple check before you start cutting concrete because if you misplace those and it lands on a rack, you got to pitch there and you need to have tracks. It really can disrupt the mobility of these racking systems if just by, and it's as simple as a contractor not really knowing, hey, there's a footer underneath this. I got to move it over by 3 feet. They move it, and then next thing you know, it lands right on your track. So like just triple checking drain placements and being on top of that is an easy thing to, catch, in early designs.
Yeah, and
And
Just go ahead, Mike. Sorry for
Yeah,
interrupting.
no, yeah, that was it. Yeah.
I was going to say, to piggyback off of that, it's like we were during our design period, it's like we made the mistake of putting our trench drains towards the front of the room. So they're in the front of the room under the racks. We have 48-foot racks, 3 stories tall. And the reality is that we lost 8 inches due to pitch. So 8 inches of vertical height was lost. And when you're working on these multi-story canopies, it's like 8 inches is a lot of space. That's 8 inches that could have been spread within 3 canopies. And it definitely caused a little bit of problems, and it was an early engineering flaw, is what it was. It was working with systems and definitely centering those drains, making sure those drains are minimizing the grade of your drain pipe underneath that bottom first bench, makes a huge difference in designing a facility.
Yeah, agreed, Brent. I can't even count on one hand how many times we've seen or trench drain placement play a role in the racking layout. So thank you. Now, Michael, you started to touch on this, but how bad does drainage contribute to contamination risk over time?
Yeah, this is one of those issues that it doesn't usually show up all at once. It builds gradually and then becomes a real problem. And I'll just say it again, I've got some trauma and PTSD from some of these issues. So high level, bad drainage is a slow accumulator of contamination. So first you get standing water, which creates an ideal environment for disease. The disease, and we're seeing a lot of disease in cultivation facilities. A lot of people are having blooms these last couple of years. So a lot more people are talking about Pythium, Fusarium, in these biofilms. So it doesn't take much, just moisture and organic matter. From there, you see organic and salt buildup, plant debris, algae, nutrient residue collect around drains and low spots on the floor, turning them into ongoing contamination sources. So then you start to layer in traffic. And I always say, the people that work in the systems are usually the spreaders of the pests and disease, sadly. And I think it's why so many people put so much attention towards PPE and what spaces you enter and when. But the traffic I'm talking about, it's foot traffic, carts, and lifts that then spread this contamination throughout the facility, turning a localized issue into a much broader risk. So you also get localized humidity increases when you have pooling on the floor in your facility under a tray. You already potentially have, as we talked about earlier, microclimates from your airflow. Well, now you have a second layer of a variable that is now adding more to these microclimates. And so finally, maintenance becomes a big issue. Poorly placed drains are harder to access, like I was talking about, that they get cleaned a lot less often. A lot of people will like sterilize their entire room. And then when I'm kind of doing deeper audits and stuff, I'll pull up the drain trenches. And I mean, the room, everything you can see is spick and span. And then you pull up the drain and it is just full of plant material, algae, fungus gnats, whatever else might be kind of breeding in there. So, the simple principle to remember here is if water doesn't move, contamination builds. So it's really getting those pitches right, and making sure that you don't have this stagnation, whether that's on the floor or in your drains.
Thank you, Michael. Now let's talk about space planning, specifically vertical constraints that often don't show up on paper. How often do teams underestimate the clearance needed around and above cultivation racks to properly support airflow, HVAC distribution, and maintenance access once real-world constraints like ducting, sprinklers, and structural elements are introduced? Brett, if you want to kick this one off.
This is definitely a topic that I see is frequently underestimated. It's like whether you're building a new facility or whether you're retrofitting a facility with vertical racking, a lot of people underestimate the clearance needed for everything, whether it's airflow or ducting for the mechanical equipment or fire suppression, or whether your facility needs beams to support the ceiling or not. It's like structural enhancements and things like that. Um, Everything kind of eats away at that upper space, and making sure to get with your fire protection engineers and your mechanical engineers when designing it, because in the early years of vertical racking, there wasn't a lot of fire code, and there wasn't a lot of facilities being engineered for indoor agriculture or controlled environment agriculture. You just didn't see it. So a lot of people didn't really know what to do. The engineers would look at it and say, well, this works. And it's like on paper, great. It's like if we can get it across the finish line, wonderful. But then you would have your next inspector, whether it was your fire marshal coming in, or whether it was your mechanical engineer or your mechanical inspector coming in. And you start to figure out that a lot of these things are limiting factors to the design. And another thing that I saw a lot of was just airflow. Looking at how the air travels into your capacity, like into your rooms, and how it cools your room. It's like when you're pushing racks up really close to your outputs. It's like whether you have plenums or just standard exports for ducts. It's like that air has to pass, and you need a certain amount of velocity for it to get in there and mix. And it would limit your canopy. It limits everything, or it creates deltas in your growing environment where your upper racks are freezing and your lower rack is extremely hot. Proper airflow with that clearance is probably one of the biggest things that I worked on with our engineering design, is making sure that we had mixing chambers, making sure that we had pathways and good airflow in the design. Really just to limit those microclimates, all those hot spots, because the uniformity was so key in the environment with three-story racking.
Yeah, you nailed it right there. This is a huge one because it's very easy to underestimate like the heights that you need, and like understanding local and state code is huge. And like just speaking on fire suppression, it's in one state you did it in, it might be fine. You go to another state that needs clearance on sprinkler heads that you didn't forecast in your heights. And so like, all that can eat into the height of your racking, which or tighten it up, to where you're like Brent's talking about that cold supply air coming out, just hitting those plants. Well, you create a cold, wet environment right there in that microclimate. That's a breeding ground for bioloads, and it just compounds in a negative way. So like you really need to understand the under the rack infrastructure and above the rack infrastructure and what that is going to eat into. There's just little things on like electrical buses and pathways that next thing you know, it's like, all right, we got a 4-inch bus with, and then you got 2 inches of strut, and now you're 6 inches there. And then it's just, you just start adding it up and adding it up, and you're getting into feet, So you really have to think about every detail and just, get hyper focused on triple checking all your heights and before you go all in on these systems.
Yeah, definitely. Thank you, Mike.
Hmm.
Continuing with layout, let's focus on aisle and corridor design. How should teams balance maximizing canopy density versus enabling efficient labor flow and workflow? And Brent, I've been to your facility. I feel like you did a great job at this. You kind of want to run through that?
Thank you. You know, I think this is another thing that people miss. They miss operational workflow. It's like, how are you going to get to the canopy that you're actually growing? And how are you going to efficiently put your teams of labor in there safely? Too, it's like to make sure that they can get the workload done in the time frame that's needed. And a lot of people just immediately input plants. It's like increase plant count and do these things. And the reality is that if you can only fit one person or two people in your rows, you're not going to be able to maintenance those plants. You're not going to be able to touch them. And aisle width and front entryways and working space and things like that really make a key kind of variable in your operations to prioritize repeatability and density and these types of things on your plants. Without thinking about your operations and maintaining a clear aisle, like just being able to get in, whether you're using Pipp systems to access those third levels, whether you're using OSHA rails and tracks and things like that, all of those things you have to ensure that the team can get there to actually access those plants. And we have so many things that we're doing in these systems that sometimes have to happen simultaneously, sometimes happen individually, whether it's your IPM or whether it's your workflow, like the teams in there skirting and defoliating, or whether you just need to get in there and make sure your irrigation is working properly. Aisle space and the front entry space and even the rear space all affects how many people can get in there operationally for that efficient workflow. So
Yeah, absolutely. I can reinforce pretty much everything you said there. It's got to be a balance of people, process, and airflow, right? For these aisle spacing. And like when you got to get people in there to work, you got to have enough space. And like you got to realize that these benches don't move flush together, right? There's inches in between these things. They never butt up fully close. So like you'll start eating into aisle spacing. You eat into aisle spacing, you eat into workflow, you eat into workflow. It's a compounding thing. And and that can cost time. And like you said, we're operating in these facilities that are GMP and OSHA regulated. So like you can't really just work off of ladders or any, you have to be thinking of safety and can I get a forklift in this or can I get a scissor lift in this room and get up to these third tiers, fourth tiers? Like some of these places are getting tall, So being mindful of that and um because if you restrict workflow, it really compounds the rest of the operational needs. And I think that's something that can be very overlooked.
Yeah, agreed. And you guys both touched on this already, but Brent, at what point does aisle width start to negatively impact labor efficiency, throughput, and airflow mixing?
yeah, it's like I think as operators and just in general, it's like we always try to maximize canopy. We're always trying to push more canopy into a room, more canopy into a room. And I think that number tends to float around like 30, 32 inches. It's like once you start getting below that, you start creating a bottleneck for your workflow. You can't get ladders or scaffolds or fork or scissor lifts into rooms anymore, and then you start to have to compete for time. And once you start having to compete for time, then things don't get done. And I think that's just the base. And even once again, it takes it into airflow the same way. If your aisles are small, you're probably not getting good lateral airflow through those racking systems.
Yeah, I think this is another great question, and you nailed it. From a PIP perspective, most flower rooms, a sweet spot for a single working aisle is around 30 to 36 inches. That's where you're kind of balancing, like you talked about, labor efficiency, plant access, canopy density. Larger rooms, we typically plan for like 60 to 72 inches of total mobile aisle, which will allow you to have two independent aisles, and then 90 to 108 inches if you want three independent aisles so teams can move quickly and cleanly and stay productive. I think something that people are really realizing in these modern designs is the defoliation process specifically is really time consuming. And sometimes when you're running that 12 and 12 flip, you might only have 3 or 4 hours you can get into a room and you're trying to get that task done in a timely fashion. So I'm seeing a lot of kind of pro moves with having that like that third aisle be available. And I think Mike, you plan to
Yeah.
run that as well.
Even the third aisle, I mean, you give it to the canopy management side, but also like when you got to load a room with, 2,000 plants and also whip all those plants in that period in a shift, it's gonna take you all day with just a couple aisles in some of these areas. So like, and then you got to go up tiers. So like you factor that, you factor in workflow, and I think the best way to measure, like get a measurable decision on these is data capturing, right? Like, what's my plant's density? What's like plant predictability when it comes to growth? Like, what kind of veg times am I running? How many people am I throwing at this? And like, watching your yields and just having a strong base of data collection, be able to make these decisions of can I reduce my plant count and increase my workflow, and then it comes down with, aisle spacing and all of these things kind of collaborate together. But yeah, having a adequate workflow with these systems, you end up really restricting and put a lot of pressure on the teams without having a good, sustainable, infrastructure in place for them.
Yeah, it's a fine balance. Thank you, Mike. Now jumping over to cultivation to post-harvest workflow, we're running a little tight on time, but this is where we see the biggest disconnect between design and real-world operations. Michael, where do you most commonly see breakdowns between cultivation and post-harvest, and why do those gaps persist?
Yeah, before I answer that too, we usually do a Q&A session. I've been answering
Hmm.
the questions and live in the chat just to give more time for the rest of this to finish out. And I'll let
Hmm.
you guys know any questions that come up afterwards. We may have to email you the responses and stuff like that. But
Hmm.
post-harvest is where I spend a lot of my time. This is a great question because most breakdowns between cultivation and post-harvest aren't really about intent. They're structural, operational, and design driven. So the first one is a misaligned KPIs for me. Cultivation is always focused on like yield and grams per square foot, while post-harvest is focused on throughput, labor efficiency, and sellable quality. And so if those metrics aren't aligned, each team is optimizing for something different, and that can actually create friction in its own self. The second one for me is inconsistent handoffs. Variability in harvest timing, plant moisture, and batch segmentation creates instability downstream, which cultivation delivers, or I'm sorry, well, I guess what cultivation delivers isn't always what post-harvest is set up to process efficiently. And then the biggest driver for me is facility design. We talked a lot about this in our previous call, but lack of dedicated WIP or work in progress space, limited staging, poor adjacency between flower, dry, trim, and packaging, and weak material flow. There's a plant process that's a natural plant process, and it also carries all the way through post-harvest. So designing your rooms in a sequential order that flows with the natural process of the plant. So for me, these issues aren't usually people problems. They're usually system problems. What you got, Mike?
Yeah, they handoffs, process workflows and consistency, SOPs. And also, being able to manage your WIP, right? What WIP is in process right now, like work in progress, like what biomass is moving through the system. Are we bottlenecking in anywhere? And if we are, having systems in place that can, you know, not factor it based off of steady state, but factoring like some of these post-processing demands on like worst case scenarios, like where are we putting our biomass, like where could do we have proper and adequate cure rooms and cure storage, and just being able to flow biomass through even when you need to pivot is important. And even come down to freezer space, being aligned with your extraction facilities and their throughput and how much, like if they're not planning on extracting this week, the machine's down, and then we should plan on not harvesting any more fresh frozen, right? We're full. So like being aligned on that and like not operating independently and just putting processes in place to, seamlessly flow this biomass through consistently, right? We also need to be consistent. So yeah, just alignment on process and flow is, you know, you got to do it.
Yeah, and to tack onto that, it's like we couldn't talk about WIP anymore. In all reality, it's so crucial for this transfer for operations and things like that. But communication, it's like proper SOPs. Make sure you're going through your SOPs and actually developing processes for this transfer. It's like not only space, but how are they going to process through it? How is the labor efficiency calculated in this? It's like make sure the teams are really truly understanding who has ownership over these processes and how to push through them in the right order to make sure that the efficiency is proper. A big thing is just SOPs. Really, SOPs, you couldn't have a more important item for a cultivation facility is how to process through this stuff because it really helps you streamline the engineering.
Thank you, Brent. And given how much workflows vary by product type and regulations, what separates high-performing facilities from the rest when it comes to managing the transition from harvest to post-harvest? Michael?
Um, what separates high performing facilities isn't the absence of variability. It's really how well they design and manage around it. So the best operators treat the harvest to post-harvest transition as a controlled system and not a handoff. I really like when there's like a cultivation manager, or I should say, I really like when there's like an operations manager who's like, oh, I do also extraction and post-harvest. Sometimes there's not a clean handoff there. One of the things too I think is really important is if you do have one of those org charts where you have a dedicated cultivation manager and a dedicated post-harvest manager, I think it's so critical that the post-harvest manager and whoever that harvest team is does a pre-harvest walkthrough with the cultivation team a few days before so they can talk through maybe what needs to be harvested in what order, if there's a compromised issue, any challenges with the crop and things like that. So they're set up for success and not just discovering this stuff in real time day of harvest.
Yeah, I mean, if you're not planning, you're planning to fail, you know. So if like, getting aligned on process, but also, letting things happen organically sometimes and putting in process when things are working, but at the same time, like not being complacent, right? Always jumping back through process and improving upon it. There's always room for improvement in pretty much every process, and things change, things evolve. And I think it's just good to not be complacent, circle back to these processes, redo your SOPs and accountability, right? Make sure there's ownership of process, and continue to just work on that and improve that is always a progressive way to, get ahead of those reactive, like disruptive situations when it comes to post-harvest flow.
Yeah, and working through that, it's like these teams, I really is, it's like they're one team and they have to communicate as one team. It's like they have to rhythm as one team. And making sure that every single person has a say in an SOP is something that's very important. It's like they should be helping edit and critique and making sure that everybody's equally invested in these things. It really helps them to understand who is assigning the ownership of each portion and how they work together strategically. That strategic kind of processing of operations is probably the most important thing. It's like making sure the teams really blend well, they're communicating. It's not just a handoff as here you go, not my problem anymore. Something that we see pretty frequently in cultivation facilities. So
Very well said. Thank you, Brent. And finally, let's talk about the planning for the future and where that planning often falls short. Why do so many facilities fail to plan effectively for phase two, even when expansion is part of their long-term vision initially? Michael?
Um, one of the biggest misses that I see consistently in expansion is not scaling the post-harvest. We get really enamored with cultivation. It's the live plants. Again, I always think it's kind of like the sexy part of the business. But everything has to flow downstream and be prepared for it. So you need to make sure that your infrastructure and equipment are in line with your canopy growth. What often gets missed is drying, trimming, packaging, whip space. Um, Mike Lenz and I were talking a lot about freezer capacity are often not built appropriately for the future. So all this stuff can really impact your downstream transitions, higher retrofit costs, delay in harvest, bottlenecks. So, as a result, you can grow more, but you can't process more. And now you have limited sellable output and consistency. And it sounds like a great problem to have, but it's an operational nightmare.
Absolutely. And they, just getting ahead of it for future growth is just, what are your market assumptions? Like what is the demand in these markets, and just trying to come up with core, well thought out like assumptions can help you, drive better, more educated decisions on some of these growths. And like, and the failure on infrastructure, like Mike's talking about, it's like, corridor spacing is a huge one. Like it looks like you have a lot, and then when you 3x your packaging cost and you have 40 pallets that show up and you're cutting in 4 feet to your corridors, or if you don't have the proper storage space, it's, starting to think about like, where are we going to put all these pallets? How is this thing going to flow? And just keeping that in mind, because it's not always about just build more cultivation space, get more plants in the buildings, and let's just grow more weed. You really have to think on a logical standpoint is what's reality, and like, find that balance between growth, planning, scaling, and what is realistic for, facilities, what are their capabilities of, analyzing that building and seeing what its potential is, and seeing where you can get to, and just being on a grounded mindset of that.
Absolutely. Thank you. And looking back, what's one expansion decision you wish more operators prioritized earlier? And how did overlooking it impact cost, timeline, and scalability?
That one is I could just go down the list, but I think I'll keep it short. Obviously, we talked about a lot of these things, power, HVAC, but there's little things that impact it. And even, Brent even said it. It's like, okay, well, if, I'm expanding, I'm building out rooms. I might have to put HVAC on the roof. Well, if you built out a bunch of cultivation space and you didn't really forecast for a lot of these older buildings, or you're adding, say you got to add 70-ton units to a roof, like, is that steel infrastructure in that roof and can it hold it? Because it can be very disruptive if that's an afterthought and you didn't plan ahead for this. And like it can be costly as well. So like there's just little things like that, like, oh, let's just put HVAC on the roof. Well, you need to get an engineer involved to understand the loads of that roof and what it's going to take to support that, like on the front end, and like, hey, if we want to go this route, we need to check some of these boxes now because in the future it might not be achievable. So I think when it says looking back on things is, for advice for people out there is like, understanding what the direction and the business case that you want to go in and like trying to get ahead of some of those little nuance things that could totally come back and give you a black eye on design.
Yeah, and to kind of add to that, it's like just operational space. I think a lot of times when you're building out these facilities, your financial partners or your investors or anybody like that are, Michael hit the nail on the head. It's like the sexy part of the business is the cultivation. And whether that's with cash flow or whether that's with just it looks better than everything else, the reality is that everybody's trying to fill these rooms. They're trying to fill their square footage with as much cultivation space as possible. And so many people misdiagnose the size they need for operations for post harvest, for packaging, inventory, trimming rooms, all these different things. And the cost to retrofit facilities, it's like once you're in operation for cultivation, it's like you're either shutting down cultivation space or you're building out. Period. Dot dot. It's like if you don't have space, those are your only options most of the time. And they're expensive and the retrofits are very timely. So it's like if you proposed one budget, you're not going to hit that goal. It's just you're not going to reach it unless you're really thinking about everything post cultivation. You got to get in there and really understand that. And electrical infrastructure, I don't think we can harp on that anymore. It's like it's too critical. You got to be really set in stone on what your demand is going to be. Without understanding that, you're going to run into huge issues. So.
Michael, anything you want to add before? I know we're at time, so.
No, I think we're good on time here. I love these responses. I just want to thank Klutch Cannabis, Mike Lentz,
Yeah.
Claybourne Co, Brent Barnes, everyone involved here. It's always nice to collaborate with just open-minded and like-minded operators in the space. And Caitlin, I want to thank you for moderating this panel, and Noel, of course, CBT, and thank you for hosting us today. I did try and answer as many questions as I could live in the Q&A. So if you're curious, there should be responses on most of them. And we will be putting out these, will get emailed to you, and we should do a blog post. But I just want to thank everyone. Had a really nice time with you today.
Yes, thank you, Michael and
Thank
Brant,
you.
Caitlin.
Oh,
Thank
sorry.
you.
Thanks, guys, all of
Yeah.
you. And thank you, everyone, for who joined us. And thanks to Pipp again for bringing us this awesome webinar. Good to see everyone.
Great. Thank
All
you,
right. Have a
Noel.
great rest of your day.